Today we're going to look at section 4.5, solving quadratics by finding square roots. Our objectives are to take the square root of a number, to be able to find the conjugate in order to rationalize the denominator, and to be able to solve equations using square roots. So how do you simplify square roots? We, quote-unquote, take out anything that is a perfect square, which means that you take out front of our radical anything that has two copies of the same factor. So you're probably used to more common ones. For example, the square root of 9. The square root of 9 is 3, and the reason it is because there are two identical factors, or the factor of 3 has a copy. We're looking for pairs. Just as the square root of 64, 8 times 8, has a copy of itself, so we take it out. We're looking for pairs. But we're also going to talk about problems that are a little bit trickier. For example, the square root of 12. 12 doesn't have just two copies. It actually has many different factors, none of which just give me a simple two pairs. So we know 12 is 4 times 3, but 4 can be broken down to 2 times 2. Here is my pair, the one that has two copies. We pull that out or take that out front, and then whatever doesn't have a pair, we leave inside. So 2 radical 3. So hopefully this is somewhat of a review for you guys. So what does it mean to rationalize the denominator? We're going to be using square roots, and we're going to rationalize the denominator. So hopefully you remember the word rational from our rational numbers. Okay, a rational number is a number that can be written as a fraction. So what our goal is if we have a denominator that is not rationalized, which means all of the numbers in the denominator cannot be written as fractions. So for example, if I look at the denominator, if I put the square root of 7 in the denominator, this is not rational. This is an irrational number because square root of 7 is our non-terminating, non-repeating decimal, which cannot be written as a fraction. So if you remember, we can multiply the top and the bottom, our numerator and denominator, by the square root of 7, because in essence this is like multiplying by 1. We can get 8 square root of 7 over square root of 7 times the square root of 7 doesn't cancel out. It's the square root of 49. 7 times 7, but the nice thing about that is the square root of 49 is 7. And now my denominator is a rational number, okay, because 7 can be written as 7 over 1. But we're going to be dealing with problems that are a little bit trickier. And in order to do the trickier problems, we're going to need to know about something called a conjugate. So what if we have a radical in the denominator, but it's not alone? So for example, if we have some number a plus the square root of some number b, the conjugate of that would be a minus the square root of b, okay? And we're going to end up using this a lot throughout the year to kind of help us simplify problems. So a plus root b, the conjugate is a minus root b. Now the nice thing about conjugates is when we multiply them, so if I have a plus root b times a minus root b, this should look familiar from our factoring unit. Remember when we factored difference of two squares, we got, say, a plus b, a minus b from our factors if we had a squared plus b squared? Well, the nice thing about this is if I was to distribute, I'm going to get a squared minus a times root b plus a times root b plus root b times root b is just b. So the nice thing here, if you notice, my two middle terms end up simplifying to 0. So I just get a squared minus b. And that's why we multiply numbers or our irrational numbers by their conjugate, because our irrational numbers end up zeroing out. And then we get a squared plus b. So that's what we're going to do a couple practice problems. So here is 7 divided by 1 plus the square root of 5. So I need to rationalize this. And again, there's nothing really wrong with this answer, 7 over 1 plus root 5. And a lot of times you would leave this even when you get to calculus. They actually prefer this sort of answer. But a lot of times in past, we don't like to keep a square root in the denominator, so we need to get rid of it. But you can't just multiply top and bottom, our numerator and denominator, by root 5, because we'd have to distribute it, and then I'd get another square root. So instead, I'm going to multiply by the conjugate. And if I multiply the denominator by the conjugate, I have to multiply the numerator. So that way, it's like I'm multiplying by 1, which doesn't change my answer. So I'm going to multiply top and bottom by the conjugate, and then go through the algebra. In the numerator, I'm going to distribute. I'm going to get 7 times 1 is 7, minus 7 times root 5. Outside numbers stay with outside numbers, inside with inside, so 7 stays on the outside, 5 stays on the inside. Over Now I'm going to distribute 1 times 1 is 1. Now for the first time I'm going to actually show you the whole distribution. So 1 times negative root 5 is negative root 5. Root 5 times 1 is a positive root 5. And root 5 times root 5 is the square root of 25, which is just positive 5. Oh, I'm sorry, it should be a negative because it was a negative square root. Put a little negative in there because it's a positive times a negative. So the nice thing about this is our middle terms, negative root 5 plus root 5, okay, simplify to a 0, so I have 7 minus 7 root 5 in the numerator, divided by 1 minus 5 in the denominator. Well, 1 minus 5 is just negative 4. So I have 7 minus 7 root 5 over 4. You could separate this into two fractions. Negative 7 fourths. Two negatives make a positive. 7 root 5 over 4. Both of these are acceptable answers. It just depends if you were doing some sort of ACT problem or any problem. I just want you to understand that if you saw both of these, you do realize that they're the exact same answer. Let's try one more. This one ends up being a little bit more complicated, not because of my denominator, but because my numerator has a fraction or has a radical in it, which just makes the algebra a little bit tougher. So now, because this says 1 minus root 2, the conjugate would be 1 plus root 2. You always just change the sign in the middle. So I'm going to multiply my numerator and denominator by 1 plus root 2. Okay, and then do a little bit of the algebra. Now, I have to be careful in the numerator. I just don't have a single term that I'm going to distribute. I have two terms, so that means I have to distribute both, or most people like to use the word FOIL. So I'm going to distribute the numerator. So 1 times 1 is 1. 1 times root 2 is root 2. Now I go to the root 10. Root 10 times 1 is root 10. Root 10 times 2 is root 20, which is not a perfect square, so I'm going to leave it as the radical 20. Over. Now if I look in the denominator, 1 times 1 is 1. Now I should know that when I multiply by the conjugate, I'm going to get a positive root 2 and a negative root 2, so I don't have to worry about writing that because it's going to zero out. But a negative root 2 times a positive root 2 is going to be a negative root 4, and the square root of 4 is 2. So 1 minus 2 is negative 1. Now if I look in the numerator, to add and subtract square roots, they have to be like terms, and to be like, the inside value has to be the same. But let's see if I can simplify any of these. This is 1. Can't do anything with that. The square root of 2. 2 is just 2 times 1, so I can't break it down any further, so I'm just going to write plus root 2. The square root of 10, okay, so let me show you over here. Square root of 2 is just 2 times 1. I don't have any pairs, so they would both stay inside. Square root of 10 is 2 times 5. Can't break them down anymore. These are prime, no pairs, so they would both go inside, which stays as the square root of 10. The square root of 20, I could break down to 5 times 4, but 4 can break down to 2 times 2. Here's my copies, my 2. So I can pull out a 2 and then leave a square root of 5 inside. But now if I look, I have a root 2, a root 10, and a root 5. Even though I changed the square root of 20 to 2 root 5, I still don't have any like terms. But you would not want to leave your answer like this. We don't like dividing by a negative 1. So instead, I would take each term and divide it by a negative 1. So I get negative 1 minus root 2 minus root 10 minus 2 root 5, and that would be my final answer. And that's how you use multiplying by the conjugate to help get all your denominators rational. So now let's go to some more basic solving ones. I know you've seen some of these before, but I want to go through them again. So if I want to solve for x, the nice thing about this is there's only one single type of x. It's x squared. Okay, I don't have x squareds and x's like we did in the factoring section. So my goal is to isolate this or get it by itself. So what I'm going to do is first subtract 2 from both sides. And again, what I want to get by itself is the x squared. So I'm going to divide both sides by 3. And I get 16. But now I need to get the x alone. How do you get rid of a squared? You take the square root. Anytime you physically do this to both sides, we're going to get a plus or minus answer, because if I want to solve for x, x could have been a positive 4, because 4 squared is 16, or a negative 4. Negative 4 squared is 16. And I get two solutions. Again, anytime you are solving, If you get an answer, you can always substitute it back in to see if both answers work. And you should get two answers. We'll talk about this more later, but anytime you have a problem and the highest degree is 2, and we call this the degree, our exponent, that means we're going to get two answers. Now, both answers could be exactly the same, but when we solve, we should get two different answers, or two answers. Let's try this one. Again, it's not very difficult, but I should notice that I have an x squared on the left and an x squared on the right. So what I want to do is combine like terms. It doesn't matter what side you move it to. I'm going to move the x squareds to the left. Okay, so I'm going to subtract 5x squared from both sides. So we get negative 3x squared minus 7 equals negative 31. Add 7. So I'm going to get negative 3x squared equals, okay, and then I'm going to get 24, but it should be negative because I have more negatives. Divide both sides by a negative 3, and I get x squared equals a positive 8. So again, I want to get the x by itself. I'm going to take the square root of both sides. So I'm going to get x is equal to plus or minus, because again, we took the square root of both sides, the square root of 8. 8 is not a perfect square, which means I can't break it down where I don't have a square root left. But I can break down 8 to 4 times 2, 2 times 2. Here's my copy. So x should equal plus or minus 2 root 2. And that would be my final answer. And we should always simplify a radical if possible. Let's look at example 3. Again, this is similar, if you look at the left-hand side, to our vertex form that you guys saw earlier when we were graphing parabolas. But again, there's only one x in here. So I want to get this by itself, so I want to start moving things to the other side. The first thing I'm going to do is multiply both sides by 3, which gets me x plus 1 quantity squared equals 21. But now, the only thing I can get rid of is the 2, or squared term. So I'm going to take the square root of both sides. Taking the square root of a squared gets us just the x plus 1. I have plus or minus the square root of 21. 21 is not a perfect square, and if I try to break down 21, I should know it's just 3 times 7. Those are my two prime numbers, so I will never get a pair. So I just leave it like this. Now I need to subtract 1 from both sides. These are not like terms. I can't combine them because they don't have the same radical, which is our radical 21. So I will write this first. We typically put the plus or minus in between the two. And then this would be my solution. X equals negative 1 plus or minus the square root of 21. So let's look at a word problem, our last problem. When an object is dropped, its height h can be determined after t seconds by using the model h equals negative 16t squared plus s, where s is the initial height. So we're just going to use this equation, and the reason we are going to use it is because it has t squared in it. So if I'm solving for time, it's the same thing as solving for x squared. How long, so I'm asking how long, so that is t. That means I don't know what the t value is, I'm looking for it. Will it take an object to hit the ground if dropped from 50 feet? Those are the three important pieces. How long is the t? Hit the ground, well, it says when an object it's at a height, well, that's our h, and drop from an initial height of 50 feet, that's our s. So let me solve the first one. I know h equals, I'm just going to write my formula, negative 16t squared plus s. I know t is what I'm looking for, that's my unknown. I know my initial height is 50 feet. Now this is where some students get stuck. They're like, well, I don't know what the height is if it has to hit the ground. Well, if it hit the ground, it's at a height of 0. So now I'm going to just, because I just have one t, or one, I don't have t squareds and t's, I'm going to subtract 50 from both sides. Okay. I'm going to now divide by negative 16, so I'm going to get a positive 50 over 16. So next, to solve for t, I want to take the square root of both sides. And I don't have to worry about reducing it because it's not my final answer. So t should equal plus or minus. Now, I'm going to get the square root of 50 over 16. But this is a word problem, so I want to answer it more correctly. First of all, I should realize that time can't be both positive and negative. Time is only positive. So when I write my final answer, I'm going to say it will take Now I want to figure out how many seconds. It doesn't make sense to give a square root answer. So if I type the square root of 50 divided by 16 in my calculator, Okay, I should get 1.77 seconds. I'm just going to round to two decimal places. And that would be my solution. So now let's look at the second one. Okay. The second one, I'm going to use the same formula, but now it says what is the initial height? So now I'm looking for S. If the object takes 20 seconds, that's my T, to hit the ground, and I know that is my H is 0. So I'm just going to substitute 0 equals negative 16. My time is 20 squared, okay, plus S. So all I'm going to do is 0 equals, order of operations says I have to do the 21st, 400 plus S, 0 equals. So now I'm going to multiply this. I get negative 6,400 plus S. So S equals a positive 6,400. So my answer would be, what is the initial height? 6,400 feet. Okay, and it's just because we were dealing with feet earlier in the problem. And that's how you would solve this type of problem. Hopefully feel a little bit better about taking square roots of a number. Again, looking for those pairs, which should be review. To be able to find the conjugate in order to rationalize the denominator, which is a skill that you're going to use throughout this year, and to be able to solve equations